What's up, everybody? Welcome back. Today we are once again working on writing an SVG renderer. The context is we are writing a window manager, right? Look at this bad boy, a couple windows. Look at this. He's transferring GPU frames from one app to another, rendering them in these little windows. Bada bing, bada boom, doing some Wayland. We're getting somewhere, right? But if I want to use this thing for real, we have to, be able to maybe like launch apps, click on some buttons, maybe present windows, right? And if I look at my real taskbar, I've got icons for things, right? So if I like open Blender, right, which we might do sometimes, we want to be able to show this guy, like this little fancy little icon, right? And you might think, well, we spent all this time running PNG renderers, so we're good to go, right? Wrong. If we look at what the Blender icon is, find here, it's a freaking SVG. And we could just like import some library that renders SVGs, but what's the fun in that, right? We can't say we have no dependencies if we cheat and we use some like library to render SVGs, right? So we gotta do it ourselves. And so if we look at this thing, we are kind of lucky. Maybe we'll open it in Vim for some syntax highlighting. There's only one command in this particular SVG. We will expand to more in the future, but there's only one. This command is kind of fucked though, right? If you look at like maybe this string of characters, you might say, what the absolute fuck? Or maybe this string of characters, you might say, what the absolute fuck? That's not a number, right? All of that is like one thing. So we wrote a parser for this thing that can extract the meaningful data out of this. The way you're supposed to interpret this actually is, that if you see a minus, that you're like starting a new number, right? So like the white space is optional. If you see a C, that is like a new command of the path that is being drawn, right? So here it's like there's a coordinate with this X, this Y, probably. Then new command start, new X, new Y, right? Same thing if you see like a number with 2 decimals, like this. This is like one number here, and then the second number starts here, right? So we wrote a parser that can parse this thing out. If we run this thing, we get, a new path, and we see that he is splitting out the command names for these things as well as their coordinates, right? So they're like, hey, move the cursor to this position, then draw a Bezier curve starting from here with these control points ending here. Then do that, then start there, render a new Bezier with a couple control points, end here, etc., etc. And now that we've pulled this data out, we should actually do something with it. So that's the plan for today, is to try to start working towards actual rendering. I haven't really thought too hard about how we're going to do that. So we'll kind of just fly by the seat of our pants, do something, but that might not be where we end up finally, Okay, so we have a thing where we handle this path. And this path right now is just logging the attributes of this thing. What should we do is the question. That is the question. My thoughts are that we never finished the emoji rendering stuff from the text renderer. But I believe that there is a lot in common with text rendering, right? So I imagine that we probably want to do like TTF lives over here somewhere, SVG lives under here somewhere, and they both point towards some sort of like renderer, right? This is, I believe, what like browsers and stuff do. I believe I've seen like people use Skia for this type of thing. I think that's like Google's 2D rendering library, I think. Yeah, 2D graphics library. So like this is like an architecture that makes sense. Right, so having someone that lives down here that we can like push data from our SVG into as we parse it, then maybe render it at the end might be good. I don't know if maybe doing something where we render incrementally as we're parsing the SVG makes sense, right? Maybe for really big SVGs, that's important. But I would imagine that the majority of SVGs that we're going to be parsing are relatively small. So probably where we start here is like, as we parse the SVG, we like build up some sort of render list, right? Of like all of the components that we want to render and all of the parameters that come from that. And then maybe we like run the renderer over this batch of shit at the end. At least that's like a good initial starting point. If we find that we need to do lazy rendering, maybe we add a way for like this list builder to like checkpoint himself in some way. Call it Stencil. That's pretty good. That's pretty good. Stencil maybe as well. I do like that idea. But yeah, let's start here. And I guess we kind of have like two options of where we start here. One is immediately exporting the SVG stuff into this thing, or one is to try to like build this renderer first, feed it some data manually to draw like a triangle or something, and then come back. Let's start by exporting. We can always do the triangle case later if there are bugs, but let's just start here. So handle path. Handle path probably constructs, well, probably have some sort of like, at the top level, we probably have like renderer here, right? I don't know yet. And then probably we're going to want to have some sort of like command list, right? Something like this, maybe. And then this guy comes in here, right? And as we are parsing this like path node, we are like pushing shit into this command list. Well, this command list, as of right now, should just take the outputs of the path parser, right? We don't really have anything other than these things. So let's do that for now, where each path, does each path get rendered independently? I don't really know if SVGs render like bottom to top or what. Can we look that up? And instead of looking it up like good people, we'll use LLMs because we don't really care about correctness here. I'm just going for vibes. So like is SVG render order sequential from top to bottom? i.e., can I just blit to the canvas as I parse? Are there layers, etc., etc.? Let's just see what he says, and we'll trust him. It's essentially document order. Okay. It's DOM order, so okay, you can so is it top to bottom or bottom to top? Is it top to bottom or bottom to top? Question mark. Back to front. Painted on top. Oh, okay, so we probably can for now just render it as we go. So maybe we say, this is giving us, maybe we just like rip it on the renderer, right? So we have like render here. And maybe we have like commands on this thing that's like move to, right? We have like, you know, paint Bezier. Well, okay, hold on. Let's think for a second. So when we are drawing something in an SVG, we're gonna have like maybe some path, right? And I believe if I were to write this, I've seen like Blender SVG has like a fill attribute here. I would assume that like we create one stroke like this, and then we define, after we've defined the stroke, what we're gonna do with it. That'd be my guess, right? So like I would guess that fill is an option, but I would also guess like outline is an option, right? I would guess. So can we look at like SVG path attributes? You know, like, is there, I know there's fill, but there's also stroke, right? So we see this. So SVG stroke fill, like maybe fills and strokes. Basic coloring can be done by setting two attributes in the node, fill and stroke. Okay, sure, right? So this is pretty clear already. So if we were to change this to stroke, is stroke just with a color or what? Stroke is with a color, yeah. So if we were to open this SVG, hold. Did I save? Let's just change all these to strokes for a second. Oh, there we go. I don't like that I have to open with Blender, but that is promising, right? So we do have this idea of take a path, do a thing with it afterwards. So our API has to reflect that in some way, right? So I think let's kind of call this a path here. And then like maybe we do something like pub function render path, right? Who takes it a path. And maybe we have like stroke fill, etc. But we'll come back to that later, right? Which means that this guy maybe initialized with some allocator. I guess we probably do like the stud style where we have like an arena. Arena's good enough for now. And we kind of store our actions. Do we store actions or what? I don't know. Maybe actions, sure. And for now, this will just be the thing that came out of path parser. So this like, you know, one of these guys essentially. Move, line, horizontal line, vertical line. No, this is like too compressed. Like you can skip a lot of this stuff. So let's say that we define our own actions. And maybe we do something. This is a union probably. So we're gonna have move to a point. Okay. And then we will have line probably. Line 2 points. Bezier, cubic Bezier, which will have you know, control point 1, control point 2, and end. Okay. And then quadratic Bezier, which is just one of these, I think. One control point. Sure, let's start here. And as we iterate this stuff, then we can kind of push this into something. So let's make a new path. Okay. And we'll say maybe this is on a scratch allocator, probably. Because I don't think this needs to happen. This needs to leak outside of the current scope. Are you sick? I just I've had like a constant lost voice for months. I keep yelling. I keep yelling. Void is so ominous. It's so true. Get in the void, baby. Okay, render path, and then we're gonna have to like push something in here, but it's gonna depend on what we got, right? I think that as we build this thing, we're gonna have a cursor here, probably. And as we init this thing, we're probably gonna do something like cursor is 0, 0, I would assume. Good afternoon. Will this taskbar use WR layer cell? Probably not. It's probably not. Actions is going to be a stud util runtime segmented list, I guess, of actions. Okay. I guess technically the cursor doesn't need to get initialized here. Because the cursor is kind of part of the render path. So I think it's just this. In which case, like, can we just get away with not defining this at all right now? That's a possibility, right? We might be able to just say, like a path is just the array of actions, right? Just fuck it. That seems fine. Okay. So now this guy needs to like define maybe like a default size 16 seems like a reasonable number of actions to expect, and then like what is like a reasonable number to like explode on? Fix me, find a reasonable upper bound, right? But like it's probably something like we have like array, we have this type that we're using is kind of like a list of lists that get like lazily allocated, each one doubling in size. So like, if we want to have like 32 wasted U sizes at the start, then you can kind of do like 2 to the power of 32 is approximately how much we can store, if I remember correctly, ish. So we can make this number pretty big without it being a problem. Let's just do like 32K for now, and then God, is action a point or a path? Neither. An action is an instruction to move the path along, I guess. So we're just doing a little bit of conversion into like a generic format. Okay. So if we see an abs move, this is yeah, I would like to convert everything into absolutes if we can, which means that maybe move is not even an option in our thing. Let me think. No, I think that's fine. I think it's fine. So abs move, we say render path, append. I guess we need to try here. I'd like to see my abs move. Thank you. So this is a move with x is mx, which means that as we build this thing, we do need to store a cursor. Wait, so I'm back. I'm back to thinking that we need to do this a different way. Because if I want to convert all of my relative moves in the SVG to absolute moves in here, well, maybe that's the job of the SVG conversion. Maybe that's fair. Maybe that's fair. So our cursor is a renderer point. Maybe. That seems fine. And then as we do these things, we update the cursor. Right, so here we go, like cursor is equal to mx my. That seems reasonable. Can we stub these really quick? Just so that the compiler like understands what's happening. Okay. These things all need dots in front. There we go. Okay. So abs line. This is line 2. Cool. And then cursor just ends up in that position. Abs horizontal line. What's happening here? Very similar. Line 2, but since it's horizontal, we only have one parameter, which is its new x position. So x is updated. And this gets x, but the y position gets the cursor y here. Perfect. Vertical line, very similar, except we we move y instead of x. Perfect. Do you render with OpenGL or how? I don't know yet. Haven't decided. That's a problem for future me. Problem for future me. Can't remember what an SVG is. Is it like serialized instructions? You need to perform them in certain sequence, skip the draw, or serialized shapes that you just parse and render? I think kind of both. I think that like the path instruction that we're seeing is very much like a list of instructions, but there's also like draw a triangle and draw a square. But I think it just happens that like the path that we've got for our first thing that we're looking at is like the command version. Okay, abs cubic Bezier. So what are we doing here? We've got like a cubic Bezier who's got maybe control 1 is B0, control 2 is B1, and then end is B2, if I remember correctly. This could be wrong. Cursor position needs to just be B2. I think. I believe it's something like this. Quad Bezier, so this is the same thing. I got confused last stream, by the way. I thought quadratic meant 4, which quad does, but quadratic is like squared, you know? And cubic is cubed. So this is like the easier version of the Bezier. I just got confused. So this is like this, and then like this, because we only have 2 points, if I remember correctly. All right, Bezier sequence. I don't remember what this is. This uses a control point from the previous iteration, if I remember correctly. So the cursor ends up being somewhere in this. I need to look it up. As we just do vector graphics. Yeah, exactly. So where do they define this like sequential thing? But it follows another S command or C command. The first control point is assumed to be a reflection of the one used previously. Okay. So like, if I have a Bezier curve that's kind of defined as like start, end, control point 1, control point 2, you're going to have something that looks kind of like this. Then they say that for sequence, you, I guess, probably reflect this guy over this axis to get control point 1 here, so that you only have to define control point 2 and the end like this. Right? It's like something like that. Something like that. So I'm just going to not implement this yet. Maybe skipping sequential Bezier need to reflect C1. Okay, abs arc. This is also unimplemented. But relative move, these should be doable, right? So here, we convert these into our absolute move. And we just use a cursor here and here, right? And we say, maybe we just do the cursor part first. So that we can just use it here. Easy. Easy. Okay, relative line. Which I guess we can kind of just do like this way as well. Right? Easy. Easy. Rel horizontal line. Wow, doing the cursor first, we should have been doing this the whole time. This is way nicer. So this is X movement. So we just say cursor X is plus equals X. Oh, yeah. Easy. Wait, we're fucking geniuses. Easy. Is filling arbitrary polygons with winding orders and all that jazz on the menu for this, by the way? I think so, and because I think that we need to solve these problems anyways for the emoji stuff that we never finished. And I think it's not that bad. I think. Okay, here we're gonna do like it's something like control point 1 is a relative move from the cursor. I wonder if the relative movements for the relative Bezier are relative to the last control point or relative to the cursor for the whole thing, right? Because there's two options here, right? There's like, my cursor is here, control point 1 like this, control point 2 like this, and like this, right? That's one option. Or the other option is that we start here, go control point 1, control point 2, end, in terms of like how it's defined in the SVG, right? So I guess we need to look this up. Bezier curves. The control points essentially describes the line, blah, 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 blah. Maybe we need to actually go to the SVG spec. Because that's probably not like precise enough. Okay. Lowercase indicates relative coordinates. Multiple sets of coordinates may be specified to draw the poly Bezier. At the end of the command, the new current point becomes the final XY coordinate pair used in the poly Bezier. It's not helpful. That is not helpful. Let's ask the idiot. I'm not above it. For relative Bezier commands in SVG paths, are the control point coordinates I guess we'll say like, is control point 2 relative to control point 1 or the initial cursor or the cursor position at the start of the Bezier? Relative to the current point at the start of the segment. Okay, they're saying like this. So we'll trust them, but with the idea that it could be wrong, right? I guess like this. I guess these guys need to be renderer points. And then these guys need to be 1. And then I guess this is just cursor. Like this. And then we append to our command list cubic Bezier, C1 is C1, C2 is C2, and is cursor. Easy. Okay, next. Quad Bezier, so this is the same thing, just easier. Okay. Easy. Sequence, we are gonna say unimplemented again. I guess for both of these guys though, we should be moving the cursor, right? Because we know we can like just skip this part of the line, which will be a little nicer. And then this is also just fully unimplemented. And then I guess we need a close command 2 to finish the loop. I like that. I like that. Okay. I guess like this. Okay, so once we have our path, we should be able to render it, right? So we go, how do we want to render it? For now, maybe we just draw lines on an OpenGL canvas for uh like just to get a feel for where we're at. Red a Vulkan renderer. No, you can't trick me. No tricking. Let's make this a Vec 4. Well, does SVG, looks to be RGB, so we'll call this a Vec 3. And yeah, let's just render it with OpenGL for now. I guess we need to get this thing to like compile, and then we'll pull in the windowing library. Did we call render on this thing? Should probably do that, right? So render path, which does need self here, I guess. And I guess we'll render. We probably need to like pull the color out of this somehow, right? So for now, let's bring this back to fill for a second. And if we see fill, we'll say the color, maybe we like default it to white or something. This is probably supposed to like default color maybe comes from renderer. I'm not sure. There might be some sort of like default that we're supposed to do. But for now, let's just do white. Figure it out later. And then here we need to parse this thing. So I guess we look like this, and we, for now, just hope that this is a hex string. So if adder.val does not 0, fix me LOL safety. For now, we're just kind of hacking it. Break, I guess. I don't know. We might as well do a 0 check. There we go. Something like this. Then we can go A is, or R, I guess, is 1 to 3. Call this R string. GB, 3 to 5, 5 to 7. And then how do we convert this? Stud, format, parse, int. Yeah, a U8, R's, base 16. Okay, yep. That seems like it does something. And then we can say color is equal to RGB. Cool. I'm not sure why last stream I thought you were doing PDF and I could not understand all the decimal values were, but now I get it. We're doing SVG. That makes a lot more sense, huh? Okay, so now we have a color. So it seems like this is like a thing that kind of works. Fuck it. Like, well, not yet. Okay, renderer has no init. Sure. Well, there's nothing in it right now, so I guess we just do like this. Okay, handle path needs an allocator. Scratch allocator. And then maybe it's actually nicer to pass this in as a scratch allocator so that this guy can like choose to manage his own lifetimes. You know, he can just be like, checkpoint the scratch allocator, and then put it back to where it was later. And then, do we have scratch alligator? Scratch buff can be a meg, fuck it. And then we can go scratch is buff allocator around the scratch buffer. Okay, and then I think this is what I want. Close. Okay. Yeah, I guess it is like this. Oh, we do need to do conversion. I'm just gonna cheat it for now. I don't want to deal with this, so we're just gonna say that this point is the same type, but I don't want it to be the same point. I don't want it to be the same type, it just happens to be for now. Fix me, conversion plus real type for a renderer. Because these guys are supposed to live separately. This is quad Bezier, my bad. My bad. Oopies. Forgot our print argument there. Okay, another one. Okay. No. Yes. Okay, it's like something like this. Okay. This builds. So now we should be able to maybe like get some window open and let's do this. He wants to be init pinned, fine. If you want to be like that, that's fine. You want to have a stable memory location, I respect it. Okay. So this thing, we need to say that when we import our guy, he's got GL and GLFW for now. Until we finish the Wayland client and merge and stuff, for now we will just use GLFW. I will live with that. And then what? I guess we need to do like initialize some OpenGL shit. Okay. And then we probably want to like make some sort of render program, right? Well, let's actually just do this first. Let's do a swap buffers and just do a clear. Just to make sure that we're like, you know, set up correctly. It's clear and clear color, I guess. Oh, let's clear red. And I think we only want to render once for now, so this should pop up in a window. And then here we need to say like, while window closed, we just wait, window. I think it's fine. Well, we need to like wait for some amount in here. How do we do that? I guess just sleep for some amount of time. Sure, fuck it. Okay, cool. He does not seem to be exiting nicely. So I think that we need to like, we must need to call like, I don't want to call swap buffers because we've only rendered one time. But I think that we need to poll events or something to get it to like do something, you know what I mean? I just suspect that it's something like this. That worked, but I typed swap buffers. Yeah, there we go. Cool. Cool! So now we should be able to render once up here our guy. So when we call render, what are we going to do? I guess we will, let's clear black. We'll swap buffers before the loop here. And then we need to make the renderer do some GL shit. So what are we doing? I guess we have our cursor. We are probably constructing some sort of like OpenGL buffer here, right? So, do we make a new one or do we reuse an existing one? Making a new one seems fine. Maybe let's just draw a triangle on the screen first, just so that we can kind of get all of the pieces in place. So we need like some sort of OpenGL program. Maybe we'll just have our default like abstraction around something that has an X position, a Y position, and a transform. That comes up often, so it's like nice to just have like a nice little strong type thing for it. And I guess here we're gonna have like a color value at the very least, which lives here. Okay. Yeah, let's make it so that we make the buffer on the fly. Fuck it. Which means that here we're gonna want some sort of like scratch GL probably. Probably just somewhere to like put stuff temporarily. Which means that we can then be like, make me a buffer. Buffer here. And then can we maybe give it like some points in OpenGL space? So let's make a triangle who's got like the bottom left corner at -1, -1. I think that if he wants points that look kind of like this, if I remember correctly. Center point is 0, 1. Okay, and then the right side is going to be 1 on X, -1 on Y. I think that makes sense. Then we need to create a render source, if I remember correctly. Well, let's see. Self-prog render. What does he want? He wants a render source. So how do we make one of those? And then I think we have to like set the contents of this thing. Bind some data. Okay, sure. Does this fail? No. Okay, cool. And then we're just like render this thing with the color of color. Okay. Cool, easy. Okay, so now this guy needs his program, right? So what the fuck is that? I guess we need to take like a vertex shader and a fragment shader. Let's just, for now, we'll do this. And we will say prog is try initialize with this OpenGL allocator that doesn't exist yet. And our fragment shader, who does take in a vec3 color, we're chilling there. Var allocators is some app allocators. Just like a collection of allocators that is useful for running OpenGL applications in our world. Scratch size, ooh, nice. Which means that we don't need to manually construct our scratch up here, which is kind of nice. Which means that here it's allocators.scratchLinear. Okay, cool. Then I think we need our scratch GL as well, which was allocators scratch GL. Cool. Things are coming together. Things are coming together. This needs to be tried. This needs to be tried. This needs to be tried. Okay, I don't see anything, which is bad, but I think the coordinate spaces are fucked, right? Because, like, oh no, here this is just a triangle. Are we calling render path? Yes. Is this after GL has been initialized? Yes. Maybe. Yes. Can we do, like, can we just render with like something well defined? Red triangle. Nothing. Okay, what are we doing wrong here? Let's double check. Center triangle is 0, -1. No, oh, oops. Thank you. Good shout. Nice. Good shout. Good shout. So if we render this thing, why is he rendering white? Oh, maybe one of the other, right. The last thing that rendered was probably white. From the perspective of the OpenGL thing. Or sorry, from the like the last path was probably white. It's probably like if I change this guy to be like black or red, it will probably show up red now. Yeah, okay, go. Cool. Okay, so now instead of drawing a triangle, can we draw something of value? We probably start with the cursor at some point. It probably starting top left seems reasonable. We probably need to like we need the image size for this to make sense, right? Because the path points are defined in like SVG space, right? So if we look at this guy, I guess that's probably defined here, right? Probably everything is in the range of 0, 0 to 128, 128. We need everything in OpenGL land to be in our like basically -1 to 1 on both axes. So we can kind of take the data as we see it in the path, but then apply a transform at the end. So for now, let's just hack it by hard coding the 128s. But we're gonna have to parse that later. So let's just say that like we have width here. I guess bounds maybe, or like top left is a point and bottom right is a point or something. You know what I mean? Like something like that. And then we'll figure out what to do with that later. Okay, so we're gonna iterate over the pat points. I guess this is instruction, maybe, is how we want to call this. Okay, and now we only have these guys to deal with. We've like reduced the set a lot. I guess we should probably. Can we look at like if pathlen is 0, return. We don't have anything to do. Then we can like look at the first element here. So if path get 0 is not equal to move, or is equal to move, I think we just set the cursor, the initial cursor maybe, to the first thing. Something like this. We're really just typing shit. Why? Oh, wrong letter. Okay. So then we could do something like we see him. We should copy paste all of these guys and handle them all. Okay. So move doesn't do anything crazy. He just sets the cursor to M. Okay, line 2. He is adding a pair of points to the buffer, probably. Do we know how many pieces are going to be in this thing up front? Probably not. But that's okay. But we'll say maybe buff data here is going to be a stored array list because it needs to be contiguous of these vertices. Okay. So then we can do like buff data append. And we're going to append 2 points to this thing, I guess. Right? Like the cursor position. And then he's going to move to like the new cursor position. So we can kind of do it like this. I don't know what I want to do for cubic and quad Beziers lit. Or the close is easy, I think. I think that we set the cursor back to the start cursor. So we like define a line here for now, I guess. And we put a line here, which means that we are expecting this thing to be, maybe rendering this thing as a line strip makes most sense. For now. I don't really know. Yeah, let's do this. Maybe we do a line loop. Because I think that these paths are guaranteed to be loops. Maybe they're guaranteed to be strips at least. Let's do that. What's wrong with your voice? Yeah, great question. It's just been broken. He's just having a hard time. Okay. So then we only have to append one thing each time. For the Beziers, we're going to have to like decimate this thing and then do something with that. But for now, this needs to be render line strip now, probably. And then the buff needs to be initialized with buff data. Okay, something like this. I don't know. Okay, top left is equal to 0, 0 for now. And bottom right, we said we were going to hard coding at 128. Okay. This guy's like, I need my scratch allocator. So true. Okay. This guy needs to write down which allocator he's using for this thing. Beautiful. And then we need to apply some transform to this thing. Which I think is like this. Yeah, mat 3x3. Mat 3x3. Okay, so we want to take everything and scale. So everything is going to be relative to top left to bottom right, right? So the width of this thing is, you know, bottom right x minus top left x. Same for height. We probably, do we need to like invert this thing? SVGs are going to be coordinate space, bottom to top or top to bottom, unknown. So we won't flip it yet. But we need some sort of transform here. That probably, it wants to put like the center, we want to put like the center of image at 0, 0. Right? That's what we want to do. Then we want to scale it such that width and height are both 2. I believe. Maybe there's some like aspect ratio handling to do in there, but for now we'll kind of do it like this. So we need to start with a translation. So I guess we calculate like cx and cy, which is going to be this plus this over 2. Right? Okay, so same for y. So this is the center. So we move this by negative cx and negative cy, I guess, probably. Then we do something else, probably scale. So width is brx minus top left x. Height is the same. And then OpenGL space has a width and height of 2, so we probably go like scale this so that the width is 1 and then multiply that by 2. So maybe like this. I think it's something like that. We're really playing it fast and loose here. And then we need to write this down as a thing we're going to do this thing. Okay. I think all of that works. I mean, that is something that is in the right coordinate space. You know, we're skipping a lot of pieces. Oh, fuck. We're spamming out of memory. Why? We probably need to, like, clear some input queue or something. Yeah, there we go. Okay, cool. So can we do something first? Can we adjust the can we change our Blender SVG for a second? And maybe just do like a triangle or something, like write a known thing. So he's got to move in here. Then can we do like lines? That would be nice. What is the command for a line? So I guess we want to like, let's move to, let's draw a square. That's easier. So we'll like move 50-50. Then what is it? What is line 2? L? L to 100, 100. L to 100, 200. And then L back to, and then close. And this should draw us a triangle. If I save this correctly. Okay. Well, I guess I went off screen, huh? Because it's 128 by 128. So, can we go, hold on, oopsies. If our thing is 128 by 128, this is 64. This, which means that this is going to be like plus 32, right? Which is, this is going to be like 32, 64 plus 32 is 96, which means that this is going to be 96, 96, 32, 96. All right, let's see if that does what I expect. I forgot to save again because this thing's like marked as right only. I mean, that's close to some. Oh, we start at 50-50. Let's start at 64-64. Oops, I forgot to fucking... Okay. Cool. I mean, that's definitely something, right? We at least see a triangle, which is like on the order of what we expect, right? Now, I think our problem is mostly that we're skipping a bunch of pieces of this thing, right? Like, we're at least confident that the, like, 128 space thing has been fixed, right? Like, we are within the bounds at the, like, as we expect to be. Maybe it's upside down, but, like, we're close. So let's, I guess, start doing something. So I guess at some point, like, this was really, at some point we did, like, a... design renderer. At some point, we kind of convert SVG to render command. Then at some point, we did like initial outlines. And now we are probably doing like Beziers and arcs. Something like that, right? Okay. So let's at least make it so that if we see the Bezier sequence, we at least move the cursor to the right spot. Are all of these guys updated? Well, there's also 2 places where we're supposed to be doing this. Fuck. No, it's fine. And then on arcs, we are not parsing these correctly yet. So can we look at those? Can we look at the arc command? This thing has 1, 2, 3, 4, 5, 6, 7, 8, 9 floating point numbers, where I assume that the end of this, like, this is the new end of the cursor. Yeah, it draws an elliptical arc from the current point to XY. Yep, perfect. So, at the very least, we should be able to say, give me your end position for both of these guys. And I think we need to, like, special case these. Okay, so these guys are planning on ripping out 7 floating point numbers, I believe. So for 0 to 5, we discard some. And then we can return... We need to do a little zig generic bullshit here. But then it should just be... The value is going to be parse me a coordinate. Yeah. Let's just see if this like runs still. Good news. Oh, I guess we're not actually parsing. I guess our Blender SVG is not what we need it to be anymore. I guess we could just start with one of these paths, actually. That's kind of nice. Then we don't have to worry about this. But actually, let's just make sure that it parses. I just want to make sure. Yeah, okay. Cool. Let's just start with one path. That's easy. Easy peasy. So, because we skip every cubic Bezier, then nothing gets drawn. That makes sense. But let's try to render it. Let's try to render it. So that's in the render loop somewhere. What do we do? What are we gonna do? So the way this works is we have our cursor's start position, control point 1, control point 2, end position. And this generates some form of curve by basically like interpolating, like if you draw these lines, we kind of like take, you know, we start here on each line, draw lines between those, then take like the same like small distance into these. Have I fucked something up? Where is it? It's here. Like clearly we have to draw along these. Then is it this? Yeah, then we interpolate here to here, I guess. And then interpolate to here. And that gives us a point here. And then if we were going to do like all, as we go along these lines further, it's going to be like the same thing, but on the far side, right? So you go draw this thing, then interpolate on the far side of that somewhere, boom, and then on the far side of that, right? And then this will end up being something that goes through both those points. Something like that. So what we want to do, if we're going to just render these like as line segments on the GPU for now, I think what makes sense is to just kind of like jump for certain time steps along this thing, right? So like we can kind of like break the sampling up maybe. And so we can go like 4, 0 to 10. We'll call this maybe I. We're going to say const t is 0.1 times I. And we are going to then do something with these params. So I guess we have a, like start is the cursor. We have, I guess we just do it like this. So we have cursor in here. I guess we need to like calculate lines. Yeah. So we need to calculate our lines. So we have our A, I guess we'll call it, is going to be a vec2 to make our lives easier. And he's going to have his x position as like Bezier, the first control point, x minus cursor x. Does that make sense? No, it doesn't. No, that doesn't make sense. Can we... I want all of these things to be vectors, at least, so that we can do easy math on them. So this is going to be cursor x, cursor y. Okay. C1 is Bezier C1x, Bezier C1y. Okay. Control 2. Boom, boom. And end is end. And then I guess we are lerping from start to C1 in some way by T. Oh, easy. So we do A, B, C. We lerp from C1 to C2. We lerp from C2 to C3. And then, or to end, I guess. Then we lerp from A to B and B to C. So we'll call this like D and E. A to B, B to C, and then we lerp from D to E. By T, and then this is our sample point, I guess. And so then we can say cursor is equal to x is P0, y, no, because cursor is used the whole time. So at the very end, I guess it's cursor is equal to something. Okay. Beautiful. And then I guess we need to do this in pairs, I guess is the problem. Right, because we need to push into our buff data. No, we just push the cursor position initially, which he was already pushed at some point. So we just push P. We just push P. I believe this is right. I don't know. T needs to be a vec2. Cause zig shit. That's promising. That's promising. Can we make our window a square? Can we make our window a square? Right? Like if we open the Blender icon, which is open here, I think we're upside down, but this is probably one of these circles, right? Like it's kind of offset to the right, offset down a little bit. So yeah, I think we're upside down, but we can just fix that really quick with like a -1 somewhere. Maybe here. Easy. Easy. And then why is the color fucked? Because this is white. Beautiful. Wait, let's just do the next one now. Oh, baby. Oh, baby. I don't know why there's a hole there. But I mean, it's not bad. Not bad. Okay, and then that looks like the fucking Blender icon, baby. I mean, not very much. Like we're missing pieces, but you can see the start, right? You've got like we've got some definition, right? We've got this, and then this is probably one big arc that we're not processing yet. Right? But I mean that's something. That's something. Let's fucking go, baby. Okay, so what are we not handling? Let's make our skips a little bit more angry. Let's do a little log warn, maybe. So that they kind of jump out. All right. Okay, so I'm seeing some sequential Bezier, and relative arc is the one that's coming the most though. So let's do that one first. Okay. Looks like we've got the tail to start edge. Yeah, we're definitely forgetting something, right? Like at the end of the Bezier, we're not closing the loop or something. But yeah, I'm not sure. Okay, let's do this rel arc shit. So draws an elliptical arc from the current point to xy. The size and orientation of the ellipse are defined by two radii, rx and ry, an x rotation which indicates how the ellipse as a whole is rotated in degrees relative to the current coordinate system. The center of the ellipse is calculated automatically to satisfy the constraints imposed by the other parameters. Large arc flag and sweep flag contribute to the automatic calculations and help determine how the arc is drawn. Jesus fucking Christ, dude. What are we talking about? Okay. Might need to push the endpoint. Oh yeah, I see what you're saying. Like at the very end of the entire loop, we kind of should do like a here, render path, append. But like there's supposed to be like a close in here, I thought. But whatever. We'll deal with that later. That's minor. Okay. So elliptical arc. So we have current point right here. We have some arc, which is not a circle, it's an elliptical arc, right? So we're drawing some segment of an oval, right? So this is going to be ry, probably rx, right? We have start, which is a point in space, end, which is a point in space. So given these 2 points and these parameters, I guess also kind of the like rotation of this whole thing, right? Because this whole thing can be rotated so that the oval is diagonal, right? Like this. So we have a start point and end point. Rx, Ry. So we need to be able to derive this, I guess. And then I don't know how the fuck, I don't know what the math is to sample along this curve either. Close is probably the DSL for reuse the first point at the end. Yeah, I don't know why. I could have kind of assumed that every one of these would end in a close. But I guess that's not true. Right? Like this guy ends at a close. This guy does not. He's got like the Z at the end. So I don't know. Maybe there's like an expectation that you auto close at the end. You know what I mean? Like that's a possibility. Okay, does this spec define how the fuck you calculate these things? Because I don't know what large ARP and sweep flag mean yet either. Because those are important to presumably. If sweep flag is 1, then the arc will be drawn in positive angle direction. Oh, yeah, because I guess you don't know from these 2 points if this curve should be this or this, right? Those are, I guess we should not use red and green because those are not good for colorblind. Right, so sweep flag is determining which way of these. Oh, you're saying it's the endpoint of the Bezier curve? Yeah, am I fucking that up? I probably am, right? Yeah, I think I see what you're saying. I'm not doing T as 1.0 in that Bezier loop. I agree. Okay, so this is sweep. Sweep determines which way we're going. And then what was the other thing? Large arc. Can we just look at the picture? The picture will tell us everything. Oh. Oh, I see. What a funny way to define this. With these 2 numbers, you could have just given me the fucking center. I guess like 1 and 0 are less bytes in the document though. Right, I see. So large arc tells me, sweep tells me if I'm going clockwise or counterclockwise. Large arc tells me if I'm on the big side or the small side. But what if large arc, what happens to if large arc if we're exactly 50% of the way through? Right? Because like it seems to me oh, okay, so sweep in this is determining which side we're drawing on. Like which way the x-axis is or the center is. I'm a little bit confused about how this resolves if large arc, if we have like a 50% of the thing, of the ellipse. But it could be that as the start and end like spread apart, then like these 2 ovals will kind of like overlap more, in which case the like large arc thing will become less of a problem. There's something like that. Okay, so do they define like the math here? The ellipse formula such that theta starts at an angle corresponding to the current point and increases positively until arc reaches xy. A value of 0 causes the arc to be drawn at a negative angle. Okay. So they're not giving me the math on how to calculate CX, CY? Yeah, I guess fuck me. But at least they're telling me how to draw an ellipse. So that's kind of nice of them. That's kind of nice. I guess, how can we do this incrementally? I think we start by just adding an arc command to the renderer, trying to get like the pieces in place for like our arc won't do this bullshit, right? Our arc will be simpler in that it will be like CX, CY, we'll define these. RX. Well, I guess it is kind of true that your center is kind of implicit from the start and end, right? Yeah, I guess that is interesting. But I do think maybe we define it like this. And then we just have to be careful about, start has to be on the ellipse. Or maybe we define start and end as radii? Maybe? Radii, is that correct? I'm trying to say the plural of radians as radians. I guess radians is already the plural of radians. And then we kind of like, derive the start angle from like we find the center and the ellipse. We know where we find the start by basically like as an angle. By what? You have a point here. You like raycast out that point in some way. Ugh. Gross. You're trying to like optimize, you're trying to like find theta such that the formula for the ellipse ends here. Ew. Yeah, so you have to do like, there's some form of like ray ellipse intersection, which is just way more complicated than ray circle intersection, right? Because like if you're just doing a circle, what is it here? Well, I guess, I mean, what is theta in this world? It's probably like some bullshit, like this is the formula for a circle but stretched. Right? Is that what we're looking at here? Yeah. Right, because this is the same as like a circle formula would be r cos theta times r sine theta. But it's just the axes are stretched a little bit. Is it not easier to calculate the length of the arc and the short one is always close and the long one is always a circle with the opening? I don't know what that means. I have no idea. Do you have a formula in that green box? This green box? Parameter conversion. Oh, nice. Maybe. What is this? Consistent with other path segment notation, arcs and SVG paths are defined in terms of start and end. The parameterization of elliptical arcs will be referred to as endpoint parameterization. One of the advantages is that it permits consistent path syntax with all the other path commands. However, this is not the only way of describing arc geometry used in software and mathematics. Okay. Arbitrary points on the elliptical arc can be defined by this. This does make sense. right? This is how I would describe it. This is how I naturally want to describe it, right? Just like this, I think. Maybe. What is phi here, actually? I'm not sure. Angle, oh, sure, because this is the rotation matrix. Right, right. This is the rotation matrix of the ellipse to kind of handle like this to this, right? That's kind of what this is. This is the actual ellipse part. And this is the center. Yeah, easy. This is how I would want to describe it. I agree. Conversion from center to endpoint parameter. Okay. So given the following variables, it has to define this. I want to go the other way. I want the other way. Given the following variables, it has to define these. Yes, please. Oh, beautiful. Beautiful. They just give me the fucking math. Beautiful. Okay, cool. So, ignoring a lot of this for now, I want to represent my arc like this. So, we're going to say rotation. We want Ry. Rx. These should be floats. Cx. I guess this is center. Okay. And then we want like start theta and theta. Yeah. Yeah, yep. And they'll see like note semi-duplicated with cursor smile. Well, that's okay. Yeah, I like it. I like it. So let's just start by drawing an ellipse somewhere, right? So just at the end, can we just like render a path? Like after doing all this parsing, can we do like path is renderer path? I don't know, man. I don't know. And then can we do like append an arc whose center is at 64, 64. Okay. Is Rx, we're gonna make him, maybe 20, like 25, 32. Make it a circle for now. End theta 0. Start theta. Okay. We need to define the direction here, right? As well. I think. Delta phi, right? Delta theta here is probably delta theta's got to be which direction, right? Oh no, I see. This encodes which way you're going. Nice. So I like that. So this should be delta theta, like this. So let's say like go negative math.pi around the circle. Go halfway around. Okay. And we can even do a quarter circle. Okay. Rotation, we'll start with 0 for now. And then Ry, oops, this is just Okay, cool. And then can we go, I guess we should start with a move. Right, so we should go move. I guess it doesn't matter. It doesn't technically matter because this is defining the start position, so we're fine. Okay, so I guess we also want to render this thing. Okay. And let's render it in white. Oopsies, white. Okay, now he's mad because he's like, I don't know how to fucking do that yet. Like, so true, King. So true. And what are we doing here? So I guess we're doing the same thing. We're like quantizing around something, right? We're like kind of putting points on this thing. I guess I think this should be +1 here because the first point is already pushed. So we can do the same thing here. And this thing can be a float for now, I think. Okay. And what are we doing now? We are, I guess, doing start theta plus, like arc start theta plus arc delta theta. This is the new, theta. Beautiful. And then we just do the math that they said here, right? So we go, so we have our transform here is this is a scale, right? This is a scale by Rx cos theta and Ry sin theta. This is a rotation of phi, and then this is a translation of this guy, right? I believe that's right. So this should just be like a transform. I don't know. We're feeling it out. So this starts as a scale of arc Rx times cos theta. Okay, and then Ry times sine theta. Multiply, yeah, you're right. I should be multiplying by delta. You're right, you're right. Then rotate by arc rot. Then translate by arc cx center x arc center y. That feels kind of right. So then we take, what are we? This is not a transform, I guess. Then what is it? We just do the vector math? Yeah, so we're doing, yeah, I guess the transform is literally just the rotation. And it's like rotation matrix apply this to arc Rx times cos theta arc Ry times sine theta. Yeah, it's kind of more like this. And then our rotation matrices are always 3x3s. I guess we probably just hand code this to be something else. Do we have like a mat 2x2? No. All right, well, fuck it. Fuck it. Fix me, maybe mat 2x2 apply would be nice here. But we'll just do it as a 3x3 and then strip the third dimension after. That is easier. So this is going to be arc cx, arc cy 0, and then we do I think that's right. Then we try buff data, append, whatever the fuck this thing is, the position. So it's going to be val 0, val 1 or something. Something like this. I don't know. No field name. Is it center.x? Yeah, I guess it is. Okay. So now can we just skip the entire XML parsing and just try to render an ellipse and see what the fuck we get? Okay. I guess his initial position is he's starting the cursor up at the top left as we asked him to. I guess that makes sense. And then he's drawing the quarter circle. We could just apply the mat 3x3 if you also wanted a translation at the end. Wait. Yeah, I mean, kind of. But like, we're not applying like one transformation to a point. You know what I mean? It's like, this is the point here. I guess. Oh yeah, I guess you're right. This is like rotate, then you're right. Translate. You're right. You can do a rotate, then translate like this. And move the translation here. But it's fine. It's fine. Yeah. I get what you're saying. You're right. Yeah, so now the only problem is that the initial cursor position is wrong, but that's okay. Right? We can we'll ignore that problem for now, because I think that the like renderer is doing the right thing, assuming that the cursor has been moved to the correct position. So now we should be able to do like, make this fatter or taller. Maybe we do maybe make it fatter in X to like 50. So now we should see something, yeah, nice like this. Can we draw more than a quarter circle now? Can we draw, well, let's draw a positive quarter circle, so it should go below now. Beautiful. Can we draw maybe a 3/4 circle? Okay, we obviously need to decimate this a little bit more, right? But for now, this is close to something. And then let's try rotating the whole thing. So let's try to get it on an angle. Yeah, okay. I think that this is doing the right thing. So now what we have to do is we have to implement the conversion part. I guess we also have to move the cursor here, right? When we render the thing, I guess we just move cursor to last P. So I guess it's just gonna be like buff data items len -1. Is it like the easiest way to get this? There we go. Should we test all the way around since the data is easy? Yeah, might as well. You're right. This is 0, 1 instead. You're right. 2 pi. This does work, we're missing a segment here, but that's because the cursor started in the top left corner instead of at the correct starting position, right? So this line is supposed to go like this, which will be resolved by like the conversion process. So I think it's fine. I think it's fine. Pretty sure. Pretty sure. So now when we see, are we rel arc or abs arc? I don't remember. Rel arc. Okay. So this guy is saying compute x prime, y prime. So this is x prime is what? Okay. Phi. Well, first we have to parse this thing, I guess, right? So this thing needs to be a arc. Right? And what is in this thing? It is number, flag, coordinate pair. And what were the parameters actually called again? Here we go. Rx, Ry, X rot, large arc, sweep flag. Then we have end. Okay, so if we see an arc, we are expecting I don't know yet. So we say what was it? We need to do it in order. Okay, so it's Rx is chord elem. Ry, chord elem. X rotation, chord elem. We need a flag, which is not implemented yet, but we'll figure that out. Large arc, sweep, flag, and then end is chord. Okay, so we just need to implement like flag, which is going to give us a bool, I guess. And how are flags parsed? Flag is just 0 or 1. Buff, take 1 of 0 and 1. This returns us an index. No flag, we'll say, or invalid, I think is what we used everywhere else. And then we say, let's look at the buffer data. Zero, return false. 1, return true. Otherwise, return invalid. That makes sense. Cool. Cool. So, are we chill? Okay, we compile. Let's see what this thing gives us. Right, let's just make sure that this looks like a sane thing. Let's bring back path rendering. Invalid. Okay. So Also kind of interesting. Did I use the wrong type? Oh, yeah, I didn't update these types. Arc. Oops. What's the problem? Try. Does this fail? Wait, what's the problem? Oh, ampersand. Or star. Dereference. Dereference. Oh, this should be else. My bad. Okay. He's immediately getting angry, right? He's saying, I didn't see a 0 or 1. Probably because we need to consume from some white space first. Right? There might be some white space there. Still not happy. Still not happy. One, two, three, four, five, six, seven. Okay, that should be right. Can we look at the data of this arc, maybe? Maybe? So we see arc here, right? So we see 1 number, 2 number, 3 number, 2 flags, coordinate, right? So that should be fine. He's parsing the... He must not be seeing the 0 correctly, right? But like here, I said you can consume any white space you want, then take one of 0 or 1. Can we maybe right before the 0, 1 print? What's going on here? It is 0 at the top, at the front here. So like, sorry, like what the fuck? If b equals O, return. Hello? 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 I don't see the problem at all. ASCII 0, no? Isn't that what I typed? Right, like... Dude, am I high? Comparing this and this. That is suspicious. That is suspicious. That is suspicious. Oh, sorry, let's do a number. Comparing 48 and 48. So this should be like, I'm good. Then he returns it. Am I looking at the wrong invalid? I'm looking at the wrong invalid. We have the index. I'm an idiot. So, yep, I see what you're saying. We should be putting ASCIIs here. Good eye. Much better. Much better. Okay. So now, this is a sane set of numbers, probably, maybe. Cool. Cool, 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 cool. Dude, coding's hard. Okay, so when we see this rel arc, what the fuck are we doing? We want this. So we'll say half width. Well, what is x1 and x2? These have got to be start and end, right? They've got to be. So we'll call this half x, I guess. All right. That's what this says. We have half y, which is the y movement here. So x prime is, I guess we need cos phi is cosine params rotation. I assume that this is in radians. It might not be, right? So we have to be careful about that. But you know, we'll see. We will see. I guess we should just look, right? Radiant degrees. I mean, it does seem like they're saying degrees here, right? Can we look at the values? Are there any x rotations in this entire thing? No. So we just have no fucking idea. We have no fucking idea, huh? In degrees. In degrees, in degrees, in degrees, in degrees. X rot rad. Okay. So back to this thing. X prime is times cos phi plus times sine phi. This is half y here. This is half x here. Right? Because this stuff gets multiplied by this. This stuff gets multiplied by this. And then y prime is negative sine. And this is cos phi. Still x and y. Okay, cool. Cons, cx prime. Whoa, my God. What the fuck? What the fuck? Dude, I don't even know, like, I want, like, intermediate variables here. I don't know how to fucking name them. RX2, RY2. I guess RX2 is RX times RX. RY2 is going to be RY times RY. So this is step one. We're just going to do we need RY2 or we do? Yep. Cos y prime 2 is y prime times y prime. That's this guy. So then we have some sort of like squirt of rx2 times ry2 minus rx2 times y prime 2 minus ry2 times x prime 2. Okay? So that was all kind of in the numerator here. Denominator. Rx squared times y prime squared plus ry squared, I assume, times rx prime squared. Yeah. Whoo! And then this is all multiplied by, I guess this is like a step 2 scale. Okay, cx prime. How is this related to SVG? It looks like an ellipse formula. Well, we have in the SVG a segment of an ellipse, and we have to convert that into something that we can render. Okay, so this is am I fucking stupid? Oh, the sign here is chosen based off these. Got it. Got it. Okay. So this is going to be Rx params Rx times Y prime over Ry. And then this is all times step 2 scale. Okay, easy. Then it's negative. Hold on. I guess the step 2 scale has to, we need to pick the step 2 scale plus minus first. So this is like if FA is not equal to FS. So this is params large arc is not equal to sweep. This is how you flip the scale. Are the last two terms the same with opposite side of the numerator and the denominator? Could be simplified a bit if so. The last two terms in the numerator, I'm not sure which part you're talking about, but I think everything's different. I guess this is the same here, and this is, oh, you're saying these two, right? Yeah, but I don't want to name that. like I'd rather have this resemble this more than to find a name for this shit. You know what I mean? But I do see what you're saying. You can kind of get away with something there. Right? This and this are the same. I agree. Okay, so this is Ry negative Ry, we'll say, times X prime over Rx. All right. Step 3. So this is what is x1 and x2 again? X2 is end. X2 is end. This is backwards then, right? Yeah, right? Is x1? Yeah, this seems inverted from what I would expect. Right? Like, I would expect end minus start, not start minus end. So, I think that we got this backwards. Well, let's just double check what they think x1 is. Current point, right? x2 are the absolute coordinates of the final point, yeah. Cursor x minus params x and x. Cursor y minus params and y. Okay. Then where the fuck were we? Jesus Christ, I want to fucking rip my eyes out of their sockets, dude. Okay. So we were here. So this is the average x, I guess. Cursor x plus params and x of 2. Can we do this? I mean, it would just be so much nicer with this fucking 2x2 matrix type. Just make my life so much easier, but whatever. We're already committed. We're committed to doing it manually, so we'll do it manually. Okay. So then we're doing CX is going to be CX prime times cos phi, which we already have, nice, plus cy prime times negative sine phi, right? Was it negative? It was. Plus average x. Okay, cy, we've got sine phi here, we got cos phi here, and average y. Holy fucking hell. So this was step 3. Step 2 was computing primes. This is step 3. Okay? In general, the angle between two vectors can be computed as this. The angle function can be used to express this. Okay. Okay. Holy hell. Okay, so angle between vectors is what we're trying to compute here. So all they're trying to say is initial theta is the angle between this and straight to the right. And the angle to the movement is this same vector, but the difference between that and the negative version, right? So there's, I guess we call this v1 and v2. And then how do we pick the sign? Right, because here, where the plus minus sign here is appearing here is the sign of this. Jesus fuck. Okay. Okay. Ow. Ow, my fucking stupid ass dumb fucking head. Dude, it hurts. I can't do this much math. I guess we just start typing. So what does all this mean? The little arrow on the top of the guy means I'm a vector, I assume. So he's like, I'm taking the vector u. Is this dot product? Is that what this is? I mean, it's a dot, so it's got to be a dot product. So it's a dot b. If equation 5-4 is another way of saying dot norm a over norm a norm b a cos. Yeah, I believe so. So we'll just call this, I guess, like angle between a math vec2 b vec2, and this is going to return us a floating point number. And then we do a cos which is the dot product of a b over length. This is length, right? You said divide by, you said norm. You did norm in the dot. Oh, sure, because this is the same as u over length of u and v over length of v. Yeah, I got you. I got you. I agree. Okay. Cool. So now we have this guy, where the plus minus sign is here is the sign of ux vy minus uy vx. So this is just a cross product, right? So I guess we do like if cross 2 is, I guess, is there like a copy sign type shit? Yeah, nice. Can we do like something like this? Copy sign 1.0 with this? It seems like that's what they're saying, right? Seems like what they're saying? I don't know. Fuck it. Fuck it. Okay, so somewhere in this arc thing, we should be doing we want v1 is x prime minus cx prime over rx. Okay. So this is going to be maybe one of these. And then this is going to be y's everywhere. Okay, we have v2, which is the other thing in here, right? Negative x prime minus cx. Oh, so it's just the same thing, but with negatives, right? Right, this and this are the same, just this first term is negative. Yep. So then we have theta is angle between 1, 0 and v1. D delta theta is angle between v1 and v2. And holy fucking shit. I guess mod 360. Oh my god, we fucking got there. Okay. So we should be able to append an arc now with delta theta is delta theta. Start theta is theta. We got center is, do we have that? CXCY? I love math. Rx is params Rx, Ry is params Ry, rot is params rot. Okay. Does Zig mod handle negative numbers in the same way as spec? Who knows? Such that if f is 0, then delta, if f is 1, then... Yeah, there might be a bug here, right? There might be a bug where we're not handling fs here. Yeah, okay, we won't do... Yeah, they do have an in other words section there, which does seem kind of nice, right? So we'll just say... in other words, if fs is 0... If fs is 0... And the right side of equation 5.6, v2, is greater than 0, then subtract 360. But the right side... Oh, the right side is the angle between. So delta theta. Yeah, right? If fs equals 0, and v and delta theta is greater than 0, they're saying. Subtract 360. Else if where is the sweep flag and delta theta is less than 0. You're right. You are right. Then add, otherwise leave as is, right? Right? I think that's what they're saying here. Dude, there's like so many places for us to like fuck this shit up, like to just be wrong. But we can dream that this is correct. I'm sorry, unable to resolve a comp time value because this needs to be a F32 for this to convert correctly. Okay. What did this look like before and after? Did we actually do a thing? I lost the plot. Like, yeah. Me too, dude. Me too. Okay. For reference, we had this, and then we bring this thing back. The question is, does it look like anything has even changed? Yes. There are a couple new segments here. The good news is we're at least ending at sane locations. Right? We do see at the very least the cursor is going to the right spot. I don't know if that matters. But like that, because like what's the problem here is that there's supposed to be, this is supposed to be coming over here, right? So we're probably skipping something that's important there. That would make it make sense if that's correct or not. Oh wait, this is the new one. This is the one with the thing implemented. Which makes it seem pretty fucking wrong. Right? We have less segments, we lost things. It does seem that way. It does seem that way. Fuck. Cool. Great. We love to see it. I guess we forgot to move the cursor here, which is probably important. That might be relevant. Great news. I guess this is relative. Right? We kind of forgot all of this is relative. Fuck. Right? All of these are relative parameters. So, can we just kind of cheat it for now, where we convert these to absolute parameters? So this is going to be path parser arc. And we just do, this is sweep. The large arc is large arc. Rx is, surely Rx is not relative, right? That would be a crazy thing to be relative, right? Surely in the relative version, the only thing that's relative is this final X and Y, right? It's gotta be. Right? 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 It's gotta be. Okay. Are we missing anything? X rot is rel params. X rot? Right, I'm hoping. Do you guys think that that's right? Thoughts? 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 Do you guys think that this is correct or incorrect? Right or wrong? Yes or no? Yeah, we think it's right. Yeah. Perfect. Ship it. Can we maybe log the params? Like, do these look sane at least? Converted rel param. What am I fucking doing? Okay. So, converted rel params. Okay, so interestingly, there's a lot. We see that there's a lot of arc pieces on here, right? So can we log like the start to end position of the cursor? You wait, hold on. Here's a cheat. Here's a cheat we can. No, hold on. I don't know. I haven't really figured this out yet. Looks like it's going the wrong way around the lips. That's what I'm thinking too, right? Like each of these, like you can imagine that we're supposed to be jumping from here to here, and we're doing that by going all the way around instead of just across like this, right? That is how it looks to me. I think step 2 sign is wrong. Let's look. Where the positive sign if not equal. Yeah, you're right. Ooh! Ooh! That's pretty fucking close, man. That is pretty fucking close. Let's fucking go. Let's fucking go. I think there's just one more sequential Bezier thing being skipped. But I mean, for the thumbnail, I guess we implement it, right? Does this, oh, by the way, does this look like it's supposed to? Why am I open? What am I doing? XGG open. Oopsies. Like, is it? I feel like there's an extra circle, no? Right? Like, this is supposed to be orange on the outside. Then one circle for white? Like, what is going on here? Oh, maybe there's... Yeah, I feel like either there's supposed to be 2 overlapping paths here that are not overlapping. That's like a very real possibility. The other possibility is that there's supposed to be 2 circles in here, and like if we just colored 2 of these orange at the same time, that would like kind of work out. Check paths on the original. What do you mean by check paths? Have you looked at the Blender logo in SVG editor? You can use Inkscape. Ah, I have never opened Inkscape. Well, that's a lie, but I don't know how to use it. But you're right. Let's see. I do agree. It's worth looking at. Oh, hold on. We just gotta download a bunch of shit. Inkscape Blender. And then can I just like click stuff? Oh, it's in there. It's in there. I don't know how to make that show again. But do you guys see that? Do you guys see it? Like it's the extra path is right here, right here, right here, right here. It's the white circle is overlapping, right? So this white circle underneath. Fuck, I don't know how to make it so that you guys can fucking see this shit. Right there, right there. You see that shit? Dude, what? Right there, right there, right there. Okay. I don't know how to fucking make that more clear, but it's in there. So that's good news. So this circle here is supposed to be white, which means that this circle ends the orange, and then this circle is blue. I missed it. Well, let's just trust me. Trust me that that 4th circle is in there somewhere. Okay. I guess we just have to implement. We have to implement the sequential piece, right? So that this doesn't go. This goes away. So, what are we looking for here? It is when we see sequential Bezier. Which one are we skipping? Is it the relative or absolute sequential? Oh, sorry. What am I talking about? Is it relative? It just says skipping sequential. Great. Rel abs. Relative. Okay. So I guess if we see sequential Bezier, we need to like look at the last position. Last control is like we need to look at the last element in the path. So I guess like if render path like len is less than 1, return an error invalid. We need to then look at the last element in here. And it depends on what type of thing was in here, right? Because I think what's happening is we're supposed to have like, you know, maybe you have like control 1, control 2 with some points here. They're basically omitting this control point, right? And you're kind of just supposed to do like take this vector and apply it again, I think. Something like that. Something like that. So we're trying to like yoink out the last element so far. So if we saw cubic Bezier, then we're good. Anything else is invalid, I think. And here we're looking for B, like last Bezier, C2. It's like something like this. Okay. Then we have the cursor. So we're doing like cursor minus last control. I guess these need to be converted to vectors. This is so stupid. Fix me easy conversion to stud vectors. But I think for now we go like cursor v is vec2 with cursor x, cursor y. We have the last control vector is last control x, last control y. Then we do control offs is cursor vector minus last control vector, and then we apply this. So we say, what? Render path append. Sure. This is a cubic Bezier that we were trying to draw. C1 is going to be x is cursor vector plus control offset. I guess new C1 is cursor v plus control offset. And then we can do new C1 here. Okay. C2 is just the cursor x plus x here, the parameter that they gave us. Okay. And then the end. Wait, am I high? 0? Wait, what am I missing? Yeah, 0 here. Oops. And then cursor is equal to, we apply this, but the end needs to go in here, so we, I guess do it here. Yeah, something like this. Lots of cleanup to be done here. Let's just be clear. We're really just kind of ripping shit, right? So a lot of this is broken, but invalid. Interesting. What was it then? What the fuck am I missing? Last was line 2. Okay, what the fuck? Do I not understand this? It said that the sequence things needed to... let's read again. Several Bezier curves can be strung together to create extended smooth shapes. Often the control point on one side of a point will be a reflection of the control point used on the other side to keep the slope constant. Oh! I must have misunderstood. I thought that it was point, control, reflect over this, new control. I think what they're actually saying is it is start, end, control, reflect this. I think. So I was completely wrong. So C1, we need to find like... Oh, Jesus Christ. How the fuck do we compute that? Drawing again. So just 2 arbitrary points. I guess we take this vector, take the halfway point, and then rotate it by 90. No. We take this vector, half it. Control point 1 here, control point 2 here. It's got to be something like you take this projection, right? And then apply that offset twice this way. Didn't it say it was a reflection? But it didn't say a reflection of what? So I just misunderstood which reflection, right? Because I thought it was a reflection of the last control point of the previous iteration. But I think it's a reflection of this. Right? So how do we calculate that reflection is what I'm trying to figure out. So because we only have start, end, and control 2. But yeah, this seems right. Right? We get this point. Is there an easier way? I guess the easier way would be to take this vector, somehow invert this over this axis, which I don't know how to do yet, and then add that to this point, right? This has got to be a simple operation. It's something to do with this vector, right? This direction vector. But how? How? Math. Yeah, I mean, hold. What does this give us? This gives us basically this axis. That's all this is giving us, this arrow, which is fine. I think in this world, it is project this vector here onto this movement, this direction vector, which will give us this distance. Add this vector twice to this to get this vector. Add to this. Yeah. Okay. So let's try that. This is end C2. I guess end V. Yeah, end C2. End V. Let's make a vec2 out of the end. Okay. We are doing end. So here it's a C2 vector as well. This comes from B0. Then it's something like end C2 is C2 vector minus end vector. That gives us this line. We get start and dir, I guess, is going to be end vector minus cursor vector normalized. Oopsies. Okay. Which gives us this. So then we just project. So we go end C2 onto start and dir to reflect, I guess like 2 times is the reflection. So then we go end C2 plus reflect offset. This is going to be start to C1. That seems right. And then we just apply this. So we say C1 is cursor vector plus start C2. Yeah. Okay, that might be right. I don't know. We're really just trying it. I guess these were relative to cursor start, which I forgot. Okay, now is everything in absolute position? I believe so. What's he mad about? Yeah, this needs to be multiplied by the direction. Yep. Something like this. Holy fucking shit. That compiles. I guess we do have to push the thing, right? We did. Then what's the fucking problem? Is this even the thing? Yo, Maya, thank you for the raid. What's up, everybody? What is up? We are writing an SVG renderer because we need to render icons in our taskbar. And so here is our attempt at rendering the outline of the Blender SVG, which looks like this. Right? So we're getting pretty close. Pretty fucking close. We're not quite there, but we're close. We're just kind of trying to wrap up this last command, which is it's a relative cubic Bezier sequence. I thought this was the last one, but does not seem to be fixing the problem that we're seeing here. So maybe we're missing something else. Anyways, I hope you guys had a good time on my stream. What's up? What's up? What's up? Hope all is well. Thank you for the raid. Much appreciated for sure. Apologies that I am basically in very specific brain mode, so struggling to think more. It does look like this did fix this top line here, right? This is gone. This hole is fixed. So we did do something. It looks like this big line is actually a result of something else. Looks like. Is there anything else like screaming at us that we're missing? Right, like if I remove this warning. Yeah, that's all the warnings gone. So I think it's maybe that the arc is ending in the wrong spot. Did we forget to update the cursor? No. How the fuck do we find where this line is? Because we're so close. Oh, I guess we can try to figure out which path it's on. Yeah, let's do that. Let's try to like figure out. It's gotta be the last one, right? It's gotta be. Yeah, okay. So it's on like the big ass outline at the very end, at the big ass outside line. He is coming like around, around, around. Oh, it's that this shape has two shapes in it, and we don't support breaking it at all. Right? So if we see a move, we have to start a new path. That's probably what it is. Right? Like, yeah. That's what's happening. Is we a movement, we're rendering this thing as a line strip, but there's like a break in the line. Did you fix that t equals 1.0 for limiter? Yes, I did. I think I did. With the fix millennial said. Yeah. So if we see a move, we need to like can we do something like we need to basically like take all of this code and run it in within the loop and then clear the line buffer. I think. So can we do like maybe function render vertex list? Okay, and this is gonna be like buff data is gonna be a, I guess for now, can we just make it a slice of vertices, which I think is XYT vertex, I believe. So then we go self render vertex lifts of buff data items. And let's just double check that that does what we expect. We do need the color. Okay, let's try that. Okay, we're back. And then we should just be able to take this. When we see a move, if buff data items len is greater than 0, we render, and then buff data clear retaining capacity. Woo! That's looking pretty close. Looking pretty close. Now we are actually missing some like some segments here. It looks to me like this is in the Beziers? Could be either. Could be either. I guess there's technically this could be a problem, but I don't think that that's happening. Yeah, okay. Okay, so for I 0 to so for 0 to 10, we do I plus 1 here, which should make it so we start at point 1, which means that we append a thing here. Oh, I guess we need to append the first vertex. Like we just do this again. Because after we move, we have to set the first byte. Which should be M here, not cursor start. Oh! Come the fuck on, guys! Come on! Tell me that's not fucking sick! Tell me that's not fucking sick! Let's fucking go! Let's fucking go, dude! That looks pretty damn good! Let's go! I'm not gonna lie, I didn't think we were gonna make it. I thought we were gonna have to give up halfway through today. But that is like basically the full thing. I think any like artifacts we're seeing here are probably just like you know, like anything that looks kind of like that. That's because of OpenGL like aliasing and stuff. So there's definitely fixes there. But sweet. We now have a full outline. Now the next step is filling this thing in. But that's a problem for another day. It's a problem for another day. It's fucking huge. Cool. Yeah, I think we call it there for now. There's obviously a ton of cleanup to do, right? Like everything we wrote today is very like prototype mode. So we'll come back. I'll probably fix that off screen and then come back tomorrow or the next day to do filling stuff. Yeah. YouTube, peace. If you want to see more content, there's a Twitch, there's a Patreon, there's a YouTube member section where we post stuff that we don't post on the YouTube. If you're watching live, there's YouTube where we post stuff like this, but sometimes we're doing some amount of programming that is not like directly table of contentsable with a title and a nice little thumbnail. So anything that doesn't really fit the YouTube algorithm goes on Patreon. Check that out if you want, or catch us live most days. Maybe not most anymore. Every other day-ish, 12:30 Pacific time on Twitch. Think that's all the plugging we got to do. YouTube, peace out. Twitch, let's find someone to raid.